All right, guys, literally 7 minutes. Start your watches. We are done in 7 minutes. 8:09. All right, we got to get moving. Maybe 8 minutes. We'll see how this goes. Okay, so guys, whoa. Okay, pause. Oh no, never mind. We're okay. I got my clicker. I'm good to go. All right, so guys, the title for your notes today is the same as the title for your notes last time, except for one word. It's no longer salts. Now it's molecules. So you may or may not remember the difference. You'd better remember that salts contain ionic bonds because we've done that to death reviewing. So guys, if salts contain ionic bonds, what do molecules contain? Covalent bonds. Now guys, remind yourselves, in order for an ionic bond to form, there has to be stealing. And that is either a metal with a nonmetal or a metal with a polyatomic ion. That's what creates ionic bonds. So guys, what atom pairing creates covalent bonds? You're going to need this. What atom pairings create covalent bonds? Because guys, remember, covalent bonds are sharing bonds. So what atoms are able to share with each other? Non-metal to non-metal, remember? Okay, so guys, that's what we're talking about today, is a system of naming that works for molecules that are covalently bonded. So guys, in review, and you don't need to write this down, here's the idea. For the past several days, we have been talking about naming and writing formulas for salts. Now what we're going to do is we are going to do the same thing, only with the covalently bonded substances, and we call those molecules. Now guys, here's the deal. When you do this, there's no Roman numerals, there's no lowest common multiple, there's no working it backwards, none of that stuff. There's no parentheses, there's none of that. Guys, this is a completely different, unrelated system. The only thing that's the same is change the ending to the last substance and add IDE. That is the only thing that is the same between working with salts and working with molecules. So, how do we work with molecules? Well, first of all, we've got to be able to identify them. You may want to write this down. Guys, molecules involve the bonding of two nonmetals. Yeah. Guess what the next bullet is? Guys, good on you. Guys, that is the one exception, and it's neat that Josh remembered that. Good job. But maybe others of you remember. Guys, hydrogen is the one exception to this. If you have hydrogen in a compound, remember, hydrogen is freakishly strong and is able to bond covalently with the nonmetals, even though hydrogen is a metal. So guys, hydrogen is the one exception, unless that hydrogen is in a polyatomic ion, like acetate, the one that Mason got us thinking about, the CH3COO acetate. That's got hydrogen in it, but it's in a polyatomic, so that would still be a salt. So, with that said, guys, how are we going to name these things? Well, guys, these are the rules. Write them down. We will do four or five total examples. And then, guys, there's one more thing I got to share with you, and we're done with today. So, guys, if we're not going to use Roman numerals, and if we're not going to use parentheses, how are we going to communicate how many of each atom we need? And the answer is prefixes. Guys, just write down the word prefixes. But what do the prefixes do? They communicate how many of each atom we need. For example, carbon dioxide. How many oxygens? 2, because di is 2. Guys, you need to know the prefixes all the way up to 10. So write them down if you need, but my suspicion is most of these you already knew. Mono is obviously 1, right? I bet you knew that. Di you already know is 2. Hey. Maybe. What's it worth to you? Ooh. Yes, I do. So guys, mono is 1, di is 2, tri is obviously 3. You knew that from trigonal or triangle. Guys, 4, tetrahedral, right? Tetra is 4. Penta is 5. Pentagon, geometry stuff. You probably knew hexa was 6. I doubt you knew hepta was 7, but now you do. You knew that octa was 8 because we've got an octet rule. You probably didn't know that nona was 9, but it sounds like 9, so that'll work out. And then guys, deca you knew was 10 because there's 10 years in a decade. There you go. So, if you've got all those figured out, guys, this is the only thing that you've got to keep straight. When there is only one of the first atom, you do not add a prefix. That's why carbon dioxide is not monocarbon dioxide. There is only one carbon, but because it's first, we don't put mono in front of it. And then guys, finally this, add IDE to the end. You're done. Now guys, what we need to do is look at some examples. We'll do a few. Then when we're done with that, there's one more thing I need to share with you. It's not new material. It's just relative to how to do better on this homework assignment. And then off you go, and you'll get your homework done, I think. Can we look at some examples? All right. So guys, it goes like this. SF6. So what is SF6? What is the name? Well, guys, S is sulfur, F is fluorine, right? Now, what is the prefix for 6? Hexa, right? So what are we going to name this? And guys, watch. This is the only tricky part. How many sulfurs are there? 1. But we don't put mono in front of the sulfur because the sulfur's first. That's the only tricky rule, is if there's only one of the first atom, don't put mono. So this would just be sulfur. And then guys, there are 6 fluorines, so that would be hexa. Come on board. And then FluorIDE. And this would be what is called sulfur hexafluoride. Notice that it's 2 words, and we dropped fluorine and made it fluoride, and that's all there is to it. Can you stand it? Yeah. Not bad, huh? So guys, if you understand that, take a swing at this. N2O. N is obviously nitrogen, O is obviously oxygen. Now guys, think through this with me. What is the prefix for 2? Di. Do we call it dinitrogen? No. So guys, hold on, don't panic, think. So guys, why did we not put mono in front of sulfur? Because it was first. But that rule only applies to mono. So yes, nitrogen is first, but there's more than one of them, so it has to have the prefix. So this would be dinitrogen, and then oxygen. How many are there? one, so it would be monoxide. Why do we use the mono in this case? Because it's second. So guys, don't call it monoxide. This would be monoxide. So the rule is this. When you put the prefixes together, if you've got two vowels bumping into each other, drop one of them so it sounds better. It's not monoxide, it's monoxide. Get the idea? All right. Told you this was easy. So guys, let's try this one. Kerpow. What's this? Interestingly, both of these exist. So guys, without my even writing it down, because frankly my board's about to go kaputski, we've got one nitrogen, we've got two oxygens. So mononitrogen? No, because now it's first and we only have one, so we don't put mono. So it would be nitrogen. And then how many oxygens? Two. What's the prefix? Di. So it would be dioxide. Okay, there we can keep the vowels together because we're not going to call it doxide, and we wouldn't call it dixi, and we keep them together because it sounds better. So that would be dioxide. You good? Okay, so guys, what about going the other direction? Dichlorine. It's actually wrong. Dichlorine. Oops. What am I doing? Dichlorine octoxide. It really couldn't get much easier than this. Chlorine, what does di mean? Two. Oxygen, what does oct mean? That's it. So guys, let me give you a hint on the test. You ready? You may forget the prefixes. For example, if I had given you, this doesn't even exist, but if I had given you SF7, you may forget that fluorine is hept. But I'll bet if I gave you sulfur heptafluoride, you might be able to make the connection in the other direction and remember that hept is 7. You know what I'm saying? Given the word, you're more likely to get the number than given the number come up with the word. So what does that mean? On the test, do these first. See what I'm saying? Because in these, there may be the prefix number relationships that you wouldn't come up with if you did these first. Little test-taking strategy. That's how we roll around here. So guys, one more. What about this? Dinitrogen tetroxide. And guys, this is a place where it could be okay to keep the vowels together. You could also call it tetroxide, but either one is acceptable. What you choose to do with the vowels on these, I won't hold you accountable for. So dinitrogen, what is that going to look like? Oh, baby. I swear to you, I hit the draw. Come on, boys. All right. So nitrogen, what does di mean? 2. Oxygen, what does tetra mean? Yep, and there you go. You get the idea? All right. So guys, we're going to do something a little different here. Grab your homework, but we're not going to start on it yet. But I want to show you why what I'm about to teach you is important. So we are now on homework number 3. But don't put your notes away because we're not quite done. So guys, it goes like this. You see homework 3, right? Naming molecules. And you've got the first 10, you're given the formula, you're going to write the name, right? Then in the next 10, you're given the name and you're going to write the formula. Now change the page. This is where these get nasty. And I want to help you work through the nastiness. Guys, now they are mixed. Some of them are salts, some of them are molecules. And guys, the thing that makes these tricky is the naming and formula writing rules you now understand are completely different for the salts or the molecules. The molecules, you now understand, we use prefixes. With the salts, we use Roman numerals, parentheses, and lowest common multiples. So, the thing that's going to make these tricky is you've got to be able to tell, is it a salt or is it a molecule? So guys, think through this with me, and then we'll formalize it in terms of some notes, and then we'll turn you loose on the homework. So guys, check this out. You'll figure this out. What atom pairings create salts? Metal to nonmetal, or metal to polyatomic ion. Now guys, what atom pairings create molecules? Non-metal to non-metal, or hydrogen. So guys, how do you know if a substance is a salt or a molecule? Well, salts are metals to nonmetals. Molecules are nonmetals to nonmetals. So how will you know if something's a salt? It contains a metal. So guys, this is what you need to be able to do. You may want to get this in your notes. Differentiating salts and molecules. Can I use the word differentiating with you? Telling the difference between, distinguishing between, figuring out which one it is. So guys, how do you know if it's a salt or a molecule? Answer: determine whether the first element is a metal, sorry, that should say or. Determine whether the first element is a metal or a non-metal. So you look at the first element, figure out, is it a metal or a non-metal? Well, how does this play out? Well, guys, if it's a metal, the compound is a salt. If it's a salt, you're going to name it using Roman numerals if necessary, using that working it backwards process that was the entire last homework assignment. And if you're writing the formula, you will do that by balancing charges by using the least common multiple. Maybe we should add that. Guys, can you tell I'm making this up as I go? Yeah, the reason is because I've never taught this before. We've used this homework assignment for like 3 or 4 years, and I used to just throw my students to the wolves and let them figure out how to figure out which ones are salts and molecules. And then when it came to this part of the test, most people just got them all wrong. So I figured if I'm going to hold people accountable for it, I may as well teach it. So guys, what if that first atom is a nonmetal or hydrogen? Well, that makes the compound a molecule. If that's the case, you're going to name it using prefixes, and you're going to write the formulas using the subscripts indicated by the prefixes, which you just learned to do. So guys, with all of that said, you have this homework in front of you, which is 1, 2, 3, 4, no, 3. Guys, be careful. It switches to assignment number 4 up in the upper right-hand corner, but it's lost in the staple. So guys, this assignment is 1, 2, 3 pages long, not front and back, but 3 pages. So we're going to do the entire thing. That was longer than 7 minutes, but I'd never taught this last part before. But you still have 40 minutes to work on the homework. You should get it done. I'll put the answers on the wall. Kelsey, you still need to go to your car. And guys, if you have questions, please let me know. Dig in and let me know if I can help.